January 2005, NASA launches a unique probe into space. Its mission was to find out where Earth's water actually came from. This probe, named Deep Impact, traveled 270 million kilometers before approaching a comet. Hidden within this comet were many secrets that had been sought for centuries. Welcome back to Jam TV videos. There is only one place in the entire universe where human beings can survive. It seems as if Earth was created specifically for humans. All the things considered essential for life are present here: water, food, and oxygen. Whether or not there is another such planet in this vast, giant universe, for now, we only know of Earth as a place where humans can live without any assistance. But 5 billion years ago, Earth did not exist. The place where Earth and our solar system exist today is on the edge of the Milky Way galaxy. When our planet didn't exist, there was a giant cloud in its place. A cloud filled only with dust and gases. What happened within this cloud that caused it to transform into the planet where we live today? This cloud of dust and gases is called a molecular cloud. It contained dust particles, including grains of sand, silicon, and various metals. This cloud was born from the remnants of different dead stars. In the early universe, stars that burned all their fuel exploded, spreading their particles throughout space. These aren't like the clouds we see in the sky. They look like the ones captured by the Hubble Space Telescope. Incredibly, this cloud was 100 light-years across. That means if light started traveling from one corner, it would take 100 years to reach the other corner. To put it simply, this dust cloud was 6 million times larger than the distance between the Sun and Earth. This is the same cloud from which new stars and planets are born. And the force that creates stars and planets from this cloud is gravity. Yes, the same gravity that exists in space. Two objects in space connect or attract each other due to their own gravity. The more massive an object, the stronger its gravity. Due to this gravity, the particles of the molecular cloud began to stick together. Larger particles started attracting smaller particles. These particles began colliding with each other at high speed, generating energy that heated the core of the swirling cloud. For the next tens of millions of years, this process continued. The molecular cloud's core grew larger, spun faster, and became hotter. Eventually, it became a massive fireball, our Sun. The remaining molecular cloud began orbiting this Sun. From the particles and gases within it, the planets of our solar system, life, and the moons orbiting those planets would form. But how? This was once a mystery, but not anymore. The hypothesis about a star, our Sun, forming from a molecular cloud, was first proposed in the 1700s by German philosopher Immanuel Kant and French scholar Pierre-Simon Laplace. But at the time, it was just an idea. Later, between 1920 and 1950, as telescopes advanced, astronomers tried to observe these clouds, but looking inside them wasn't possible with visible light telescopes. Then, between 1970 and 1980, the invention of radio and infrared telescopes solved this problem. It became possible to see inside these clouds of dust and gas. Astronomers observed new stars being born inside molecular clouds. This proved that new stars are born within molecular clouds, and planets later form from the remaining particles of the cloud. But how does this process begin? Many ideas were floated, but then in March 2003, an experiment on the International Space Station answered this centuries-old question. Astronaut Don Pettit, experimenting with various items on the ISS, wanted to see how they behave in space. He made water bubbles, put Alka-Seltzer in them, and also put salt in a plastic bag and spun it. While the purpose of these experiments was something else, his final experiment answered the old question. When salt was put in a plastic bag, after a while, the salt particles stuck together because particles in space attract each other. Scientists believe that within the molecular cloud, the small and large particles, all orbiting the Sun in the same direction, stuck together like this salt. This was the beginning of planet formation. About 4.5 billion years ago, similarly, particles in the molecular cloud began clumping together, just like Don Pettit's experiment where salt particles combine. When the size of this clump grew to about 1 kilometer, the size of a mountain, its own gravity became so strong that it started attracting nearby particles, like a vacuum cleaner sucking up dirt. This process continued for the next 30 million years, and from the clumps of particles, 20 planets emerged, all orbiting the Sun. Because these 20 planets were now quite large, their gravity caused them to attract each other during their orbits, and eventually they started colliding. In each collision, two planets merged to form a larger planet. Over time, due to these collisions, the solar system went from having 20 planets to just a few, including Venus, Mercury, Mars, and our Earth. But this Earth wasn't the blue, life-filled planet we know. Instead, due to the collisions, it was incredibly hot, like a fireball. If any organic matter appeared, it would evaporate in less than a second. Life on Earth could only emerge when its temperature dropped. But before it could cool down during its early stages, it had to face its biggest threat, solar storms. Yes, the radiation from the sun. Whenever they enter a planet, they cause significant damage to its atmosphere. These solar storms also hit other planets, preventing life from flourishing there. Take Mars, Earth's neighbor. Solar storms have destroyed its chances for life. So how did Earth combat these solar storms? The secret lies in Earth's core. When Earth began forming from the molecular cloud, its temperature rose drastically, turning it into a fireball. Rocks melted, including the iron and nickel inside them. Because iron and nickel are very heavy, they started sinking towards Earth's core. Geophysicists believe that when molten iron is spun, it creates a magnetic field around itself. Since Earth's core has a large quantity of molten iron, it generates a magnetic field. The extent of this magnetic field's influence in space is called the magnetosphere. Normally, on the side of Earth facing the sun, this field extends 370,000 kilometers, about the distance to the moon. On the side facing away from the sun, Earth's magnetic field stretches for millions of kilometers. This is why the magnetic field blocks the radiation coming from the sun. At the north and south poles, where this magnetic field is weaker, the radiation enters the atmosphere, interacts with particles, and creates the aurora effect, known as the northern and southern lights. But this amount of radiation is so small that it causes no harm. The young Earth had managed to survive solar storms, but it still wasn't perfect for life. It had to go through another difficult phase, a planetary collision. How do we humans know about this? We have to go back to the 1960s. The USA planned several Apollo missions and sent astronauts to the moon for research. Initially, it was believed that the moon was a piece of Earth that broke off for some reason. But when astronauts went to the moon and brought back rock samples, these rocks didn't look like those found on Earth. They appeared to have been superheated. Further investigation revealed that the oxygen isotopes in the moon rocks and Earth rocks were identical, proving that the moon was originally part of Earth. But it had been heated extremely. Only one thing could cause such intense heating: a collision with another planet. While Earth was slowly cooling, another planet moved towards it. This planet was about the size of Mars and was named Theia. When Theia collided with Earth, a tremendous amount of energy was released. Burning fragments of Earth and Theia scattered into space and eventually began orbiting Earth. Over the next thousands of years, these orbiting fragments stuck together, just like the particles in the molecular cloud. And that's how the moon was born. Initially, the moon was much closer to Earth. Experts say it appeared 15 times larger than it does now. But gradually, at about 1.5 inches per year, it is moving away from Earth. The collision with Theia and the birth of the moon were the two events responsible for our existence today. Scientists believe that if these events hadn't happened, life might never have emerged on Earth. But how? When a Mars-sized planet collided with Earth, it tilted Earth to one side. Earth, which was previously rotating on its axis, became tilted at a 23.5-degree angle. This tilt gave Earth different seasons. As you know, one full rotation of Earth defines a day, and one complete orbit around the sun defines a year. Because Earth is tilted at 23.5 degrees, during the months when the northern hemisphere is closer to the sun, it experiences summer. In winter, that part is farther from the sun. Due to this tilt, Earth's surface doesn't experience uniform heat or uniform cold throughout the year. Because of these changing seasons, we get different fruits and vegetables. We see various colors throughout the year, and due to the monsoon rain cycle, we get clean drinking water via rivers. Additionally, the formation of the moon creates ocean tides. These tides provide nutrients to marine life. Without these tides, nutrients in the ocean would be limited to a few spots. But this raises the question: ocean tides can only form if Earth has water, the most essential element for life. So where did Earth's water actually come from? This was the biggest mystery for the scientific community. In January 2005, NASA launched a probe called Deep Impact into space. It was sent 270 million kilometers away to a comet named Tempel 1. A 350-kilogram copper impactor was attached to the front of the probe, meant to collide with Tempel 1. On July 4, 2005, this impactor struck the comet Tempel 1 at a speed of 38,000 km/h, creating a huge crater. This impact was captured by radio telescopes on the Deep Impact probe. What the telescope showed was truly surprising. When the light emitted from the collision was analyzed using spectroscopy, it was found that Tempel 1 contained water in the form of ice. This proved that water exists inside comets located in the asteroid belt, far from the Sun. But how did these comets leave their orbits and come to Earth in the hundreds of millions? Experts believe that only the largest planet in our solar system could do this: Jupiter. Yes, Jupiter is the largest planet in our solar system, and obviously its gravity is many times stronger than Earth's. A special feature is that it orbits very close to the asteroid belt. The gravity of Jupiter converted the normal circular orbits of comets, where they orbit the Sun in a perfect circle, into elliptical oval-shaped orbits. When Jupiter's gravity attracted them, they left their circular orbits. During this process, when they came near Earth's path, Earth's gravity pulled them down. Geologists believe that water wasn't initially on Earth. It arrived here 500 million years after Earth was formed. But how do we know this? Zircon is a mineral found in rocks, and water is essential for its formation. Because it also contains uranium particles, its age can be determined using radioactive decay. The age of all zircon samples found on Earth so far indicates they were formed 4 billion years ago, meaning 500 million years after Earth came into being. The birth of Earth from the molecular cloud, the collision of Mars-sized Theia, the tilting of Earth, the creation of ocean tides due to the Moon, and Earth receiving water due to Jupiter, located hundreds of millions of kilometers away. The chances for life were starting to look better. By this point, Earth's temperature had dropped significantly to about 100 degrees Celsius. But the most essential thing for life was still missing from Earth: oxygen. So now you tell me in the comments section, how did oxygen come into Earth's atmosphere? I hope you will like and share this Jam TV video profusely. Thank you so much for your loving comments. See you in the next amazing video.